Let's see how a staff engineer would tackle some of the top interview 150 questions via LeetCode. I'm somebody who has never done this before, so we'll try it out. Let's start with something easy. Merge a sorted array. Oh, cool. So, alright, I'm going to use Ruby. You're given two integers array, sorted in non-decreasing order, and two integers m and n, representing the number of elements in nums1 and nums2. Merge nums1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n. Example. Alright, so 1, 2, 3, 0, 0, 0. M is 3, nums2 is 2, 5, 6, and that is 3. Okay, well, let's do this in very short order using Ruby for our basic building blocks here. Of course, that's probably not what they want, but let's start with it. So we're going to say nums3 equals nums1 plus nums2, and then nums3 dot sort, and then it looks like if there's ever, is it such that if there's ever a 0, that 0, the last should be set to 0, and okay, so let's clean up nums1 first. Clean nums1, so this will equal nums1 0 m, and this will equal cleaned, and then nums1 equals nums3. So let's go ahead and how do we run that? Run. Okay, so what do we get wrong? So 1, 2, 3, 0, 0, 0, 3. Oh, that was silly. Forgot a period. Pretty common mistake. Oh, what did we miss this time? 2, 3. Alpha, that is the same thing. Let's see. Let's just see what we got here. Let's see what we got. Okay. 1, 2, 3, 2, 5, 6. Oh, right, we're not modifying it in place. So this is a good, so that we're currently setting the nums1 memory location to the nums3 location. So that would make sense, but I bet nums3 is correct. Let's see if that's true. One, 2, 3, 3, 5, 6. Cool. And output was nums3 1. Yeah. Okay. So this is right, except for we're not doing it in place correctly. So let us see how we can do that. So why don't we do this a sort of silly way first, and then we'll get better. So let's do nums1 dot each with index do n idx. And then what we'll say here is, actually, let's do this, nums3 each with index, and then we're going to go nums1 idx equals n. And that, I think, should work. Let's try. Accepted. Great. So that's how we get one of these to work. And let's talk through this again. So first, we only want the amount of the array of nums1 that actually matters. We don't need those zeros at the end. Then what we want to do is just combine the two arrays. And then we're just going to use native Ruby sort in place to sort that array. So now we have the answer is right here. But then we need to put it into the place of nums1. And so all we're going to do here is just loop through nums3, our newly sorted one, and just set the index at every index of nums1 to n. That way we're preserving the place in memory where nums1 is, and we're going to move it all the way through our nums3 array. So it's going to equal our nums3 array. So that's how we would do that. Now let's see, it had something in here of follow-up, can you come up with an algorithm that runs in n plus n time? So in linear time, and let's see how we're doing on this. I mean, let's just see. So in every case, I don't know, I mean, I don't actually know how this works under the hood. That could be costly. The sort is going to definitely be costly. And then we have a linear here. So it's probably not quite that good, although it's probably not so bad. But yeah, that seems to be acceptable. We'll keep going on some of these, and we'll do some more all the time.